The last few things in this section are the even odd properties of the trig functions and the basic Pythagorean identity. Now, the even odd properties can be useful when evaluating trig functions. If you just look at this picture here, what you can see is if you look at the angle t and negative t, t, right, you travel counterclockwise around the unit circle and you arrive at this point that you call xy, whereas with negative t, you travel clockwise and you arrive at this point, which would have the same x value, but the opposite y value. And that's going to be true for any value of t and negative t, right? T is always, if t is the point xy, negative t is going to correspond to the point x negative y. So the x value stays the same and the y value changes signs. So what that tells you is that since the y value is the sine, right, the sine of negative t is going to be negative y, which is actually going to be the opposite of the sine of t. And since the cosine is the x value, the cosine of t is the same as the cosine of negative t, right? They're both equal to x. So the cosine of negative t is equal to x, but that's also the cosine of positive t. And then the tangent of negative t, since tangent is the y value divided by the x value, the tangent of negative t would be negative y over x, which is going to be the opposite of y divided by x, which is going to be the opposite of the tangent of t. So the tangent of negative t is going to be equal to the negative tangent of t. So what these things mean is, remember when we did even and odd functions back in the first unit, I guess? When we had f of negative x being the same as negative f of x, that meant it was an odd function. So what this is really telling us is that sine and tangent are odd functions. And the other relationship that we have with cosine is that f of x is the same as f of negative x. And what that meant is the function was an even function. Okay? And this can be useful in certain instances, as you'll see. Okay? So bottom line here is sine and tangent are the odd functions, and cosine is an even function. And that's what we've gathered here. Okay? And what ends up happening is a reciprocal is also going to be the same, right? So if the sine is odd, that means that the cosecant is also odd. The cosine is even, that means that the secant is even. And the tangent being odd means that the cotangent is also odd. So those are the even and odd functions. So how can this be somewhat useful for us? The sine of negative pi over 6, okay? Since sine is an odd function, this means that the sine of negative pi over 6 is really the same as the opposite of the sine of pi over 6. And the sine of pi over 6, again, this I keep coming back to this whole idea of memorizing this table. It's going to be very useful. The sine of pi over 6 is going to be 1/2. So this is going to be negative 1/2. All right. The cosine of negative pi over 4, since cosine is even, this is going to be the same as the cosine of pi over 4. And the cosine of pi over 4 is the square root of 2 over 2. So that's where the even odd properties come into play. And here's them going through it using the table, right? And that's really what I did, except I have the table committed to memory, so I didn't necessarily have to look at it. And then the last thing, and we're not going to look at all these identities. We're only going to really focus on the main Pythagorean identity and the reciprocal identities. So these ones we already know, right? I mean, we know that the cosecant is 1 over the sine. We know that the secant is 1 over the cosine. We know that the cotangent is 1 over the tangent. And also, another nice way to think about tangent is that it's the sine divided by the cosine. And that's why I had said you don't necessarily have to memorize values of the tangent. You can just always think of the tangent in terms of the sine and the cosine. And then the Pythagorean identity, the one that's going to be applicable to us in this course, is this one. The sine squared of t plus the cosine squared of t equals 1. And when I first introduced the unit circle, I had showed you why this works, right? Because the idea is you have the unit circle. That's a horrible unit circle. But you have this point on the unit circle that you call xy. So this value over here was your x value. This value here was your y value. and the hypotenuse was always 1 because this is the unit circle. So then you have your Pythagorean theorem applies, right? And your Pythagorean theorem would say that x squared plus y squared equals 1. But from our definition of cosine and sine, we know that x is really the cosine. So this is the cosine squared of t, and y is really the sine. So this is the sine squared of t equals 1. So that's where we get our Pythagorean identity from. And that's going to be useful. So here's an example where we can use the Pythagorean identity. If we know the cosine t is 3/5 and that t is in quadrant 4, find the values of all the trig functions of t. Well, we can just use our Pythagorean identity, right? So the cosine t is 3/5, so we can then plug in 3/5 for cosine and use sine squared t plus cosine squared t equals 1. And we can solve for the sine. But just note again, when we take a square root, we always end up with a positive or negative. So we have to determine whether it's positive or negative based on the quadrant that the angle is in. Okay? And in quadrant 4, the sine was negative. So what's going to end up happening here is the sine of t is going to be negative 4/5. And now that we know the sine and the cosine, we can get all of the other 4 trig functions, right? The cosine of t was 3/5, so we'll do the reciprocal of that, which is the secant of t, which is going to be 5/3. The sine t was negative 4/5, so the cosecant of t, because that's the reciprocal, is going to be negative 5/4. And the tangent of t is going to be the sine divided by the cosine, right? The sine of t divided by the cosine of t. So that's going to end up being negative 4/5 divided by 3/5. And again, the keep change flip and you get the 5's cancel. So you end up with negative 4/3. And now that we've simplified the tangent of t to be negative 4/3, we know that the cotangent of t is just going to be the reciprocal, which is going to be negative 3/4. So that's an application of the Pythagorean theorem. And again, when we had done this in the past, we had probably used the 3, 4, 5 right triangle to do it, but you can also do it using the Pythagorean identity.